we consider binomial distribution. Many types of probability problems have only two outcomes or can be reduced to two outcomes. For instance, when a coin is flipped, it can land heads or tails. In a football game, a team either wins or loses. When a baby is born, it will be either male or female. Other situations can be reduced to two outcomes. If you consider a quiz consisting of a multiple choice question, even though there are 4 or 5 answer choices, one can classify them as correct or incorrect. Situations like these are called binomial experiments. It is concerned with trials of a repetitive nature in which only the occurrence or non-occurrence, success or failure, acceptance or rejection, say yes or no of a particular event is of interest. A binomial experiment is a probability experiment that satisfies the following. First, there must be a fixed number of trials. Second, each trial can have only two outcomes or outcomes that can be reduced to two outcomes. These outcomes can be considered as either success or failure. 3. The outcomes of each trial must be independent of one another. Last, the probability of a success must remain the same for each trial. The outcomes of a binomial experiment and the corresponding probabilities of these outcomes are called a binomial distribution. We use the following notations. N denotes the number of times a trial is repeated. P, the probability of success in a single trial. Q, the probability of failure in a single trial. X, the random variable, represents the count of the numbers of success in n trials. The probability mass function for a binomial experiment gives the probability of exactly X success in n trials and is denoted by P of X, which is P of X equal to n choose X times P raised to X times Q raised to n minus X. The mean or the mathematical expectation of the binomial distribution can be computed using the formula mu equal to n times p, variance npq, and the standard deviation, which is the square root of the variance. Now we consider the following example. 5 fair coins are flipped. If the outcomes are assumed independent, find the probability mass function of the number of heads obtained. Here, 5 coins are flipped. That means flipping a coin is repeated 5 times. So n should be 5. And we are considering the success as getting the number of heads. So x denotes the number of heads here. So if you let x the number of heads, success, and q the number of times tail occurs, which will be equal to 1 over 2. The probability mass function is given by, hence the probability of getting no head can be obtained by substituting x is equal to 0 in the above formula. And we see that the result is 1 over 32. Next, the probability of exactly one head can be obtained using x equal to 2, which gives 5 over 32. Similarly, 2, 3, 4, and 5 all heads are obtained as follows. The cumulative distribution for a binomial distribution can be calculated using the formula. For instance, the probability of getting at most 3 heads in the above example is obtained by the following formula, which is same as probability of getting 0 8s plus probability of getting 1 8, probability of getting 2 8s, and probability of getting 3 8s. So which equals to this 13 by 16. The mathematical expectation variance and the standard deviation can also be computed. So we have obtained mean as 2.5, the variance 5 by 4, standard deviation square root of 5 by 4. We consider another example, which is the probability that John hits a target is 25%. He fires 50 times. Find the expected number of times he will hit the target and the standard deviation. They have given that the probability of hitting the target is 25%. If we consider that as P, which is equal to 0.25, and hence Q will be equal to 1 minus Q, which is 0.75, and N equal to 50. So the expected mu will be N times P. We've obtained that as 12.5, and the standard deviation square root of NPQ, which amounts to 3.06. Thank you.